Alright, so in this video we're going to start talking about common logarithms. So this is a logarithm with base 10 is called a common log, and it can be written without the base. So over here log 10 of x can just be written as log, do better G than that, log of x. It's the exact same thing. So let's try to evaluate some of these logs. Using our knowledge of exponents, evaluate the following logarithms. So with number 17, we have log base 7 of 49. So first, I want to rewrite this in exponential form. So this 7 right here, the 7 is going to become my base. The 49 is what I'm going to be equal to. And then I need to know what my exponent is. So that's going to be my x. So I want to write this as 7 to the x power equals 49. So if you recall, 7 to what power is going to be equal to 49? That's right, x is going to be equal to 2, since 7 squared is going to be equal to 49. Let's do the same thing with number 14. 3 is going to be my new base. I don't know what my exponent is, and it's going to be equal to 27. So 3 raised to what power is going to be equal to 27? 3. So 3 to the third power is equal to 27. So those are some easy examples. Let's look at number 15 here, where we have log of 100. Make note, there's no base right there. So we can assume, based on our little bit of notes up here, that the base is going to be 10. So over here, let me erase the circle, our new base is going to be 10, and it's going to be raised to the x power, and it's going to be equal to 100. So let's think, 10 raised to what power is going to be equal to 100? 2. So 10 squared is equal to 100. Now let's look at number 16. We have a base of 12. I don't know my exponent, and it's going to be equal to 1. Now this one's a little different here, because usually we're equal to a bigger number. So with this one, try to think any number, like if I had any number right here raised to what number would be equal to 1? This one's a little tricky. So I'll go ahead and give this one to you. So x is going to be equal to 0, because if you type 12 raised to the 0 power, you're going to get 1. Any number raised to the 0 power will always be equal to 1. So that's a good little side note to make. Any number raised to 0 equals 1. There we go. So now let's look at number 19 here. Our base is going to be 9. I don't know my exponent, and it's going to be equal to 1 over 81. So now we got a fraction over here. Well, we know that 9 raised to some power is going to be equal to 81, but it's got to be a little different since it's a fraction. So here, I'm going to do this on the side. What if we had 9x equals 81? Well, we know that x would be equal to 2, right? So if we're going to have 1 over 81, then that means our x is going to be negative in this case. Because remember, if you have a negative exponent, it rewrites it as a fraction. So down here, our x is going to be equal to negative 2. So now, last example, number 20. We're going to have a base of 64. I don't know the exponent, and it's going to be equal to 4. So now with this one, we kind of have to do a little bit of reverse action here, because 4, let me do a different color, 4 raised to what power would get me a 64? Well, you should know that that number would be 3. So 4 raised to the third power would be a 64. But if it's the other way around, where I have 64 raised to a power and equal to 4, what's my x going to be? well then you want to think of a fraction. So in this case, the x is actually going to be equal to 1 over 3. And if you type 64 to 1/3, you're going to get a 4. And that makes sense, since 4 to the 3rd power would be 64.